Just tell you that we are pressing on here with chapter 21 in departures, and we're going to pick up where we left off yesterday, with one exception. One thing that I wanted to go back to was this. It was that chart that I mentioned to you guys, and that was that climb and descent table. So if you guys, you all have your approach charts and everything there. So you can pull this up and you can take a look at it. But what I wanted to do was to make sure that you guys understood how all of this thing worked. So, and one thing I was going to try here is with this. I'm going to see if I can actually draw on this bad boy. I think I can. The problem is you might not be able to see it as clearly. Let me try this. I'll do this just a little bit more. How do I make that? Come on, baby. Come on. Well, shoot. I may not be able to do that, guys. Dang it. Boy. Yeah, I thought maybe I could. No, I just hate experimenting here with all this stuff. But let's see if this will let me do what I want to do. No, it keeps shrinking back to that regular size. I'll figure out how to do that. I don't mean to waste your time with this, and so we'll just mouse around on it here. So you guys can kind of see the mouse here as well. It's a little harder to see on the background, but my God, that took 45 seconds. So what we see here is this. We see our speed coming across here from left to right. Left is slower, right is faster. And then we also see our angle of climb or descent. And you can see that we have a shallower descent at the top. We have steeper angles of climbs or descents here at the bottom. And we talk about this as being a climb gradient, but I also want to show you something else here with this in just a moment. So if you look here, one of the targets that we have here are going to be the fact that, I wonder if I can just do this. Let me try this thing, and there we go. Now I may be able to actually do something here. So if we look at this, one of the things that we look at here is about this 90 knot ground speed. Now, guys, I want you to think about that for just a second. I want you to think about a little trigonometry here, and let's start talking about the hypotenuse. Is that we're looking at that angle, and that angle is either on a descent or on a climb out. And so that's kind of getting up and out of an airport. So remember how that looks on a piece of paper. If we look at that here and we think, okay, this is going to be, well, I just keep trying to do things here that the board just doesn't kind of want to let me do. So if we take a look at this and we say, okay, here's our runway here. This is our runway. And we look at this, and let's say that this is our climb angle on the way out. Okay, that's our climb angle. And then we look at this and we think, all right, well, that's the climb angle on the way out or down, and here's the ground. So when I look at this, you've got to remember this. If I draw a line here, let me do this with a different color. If I draw a line here and here, and you look at the difference between the red line and the blue line, which line is longer? How many of you said the red line? Good job. So the red line is going to be longer. So if we think about that, we think about, okay, we have right now on this line up here, we have, let's say, an indicated airspeed of, let's say, well, it's not going to be 90 knots on the way out, I can assure you. On our climb out, let's say that we have this closer to 70 knots on our climb out. What do you think that ground speed is going to be down here on this which is going to be the shorter line? Well, you have to think, okay, you're going a greater distance here across this top, so it's actually going to be slower. So you may actually only have a ground speed of 60 knots. And you're thinking, okay, well, how in the heck do I know what my ground speed is going to be? It is because when you are looking here at your primary flight display, one of the presets that you can set here is going to be ground speed. I always have one of my options here as being ground speed, and I set this up here in my primary flight display, it's one of the options that you can select here when you're setting things up on your primary flight display. So you know that your indicated airspeed is going to be here, you know your true airspeed is going to be here, and you set your ground speed up here. This way you can look at that on the climb out. You can also do that on your multifunction display where you can set that up and look at your ground speed. The reason that I set this up on my primary flight display is not even necessarily on my departure, but I'm using this also for my approach on this, because when we look at this as well, all of our approach timing that you're going to learn about later is all done here around your ground speed. So the airspeed is great, but all of your mathematics are going to be around that ground speed. On your takeoff, you're probably looking at a ground speed in our training aircraft closer to 60 knots is your ground speed. On your approach, your target is going to be closer to 90, and possibly over here it could be 100 knots of your ground speed here. And you have to kind of look at that, because that's where, for instance, when we start looking at things here ground speed wise, that's kind of why I like to have that on my primary flight display. So let's look at this here for just a second. So if we see something on our departure that says, in order for you to have to make sure that you have the correct obstacle clearance, is that you want to make sure that you have a climb per nautical mile here of, let's say, 210. Well, you'll notice here is that with a ground speed here of 60, your 2 degrees here and 210 here, that nautical mile, these two things match at 60, which is kind of what you would expect that to be, because if you think about that, 60 knots per hour, 60 knots per nautical mile, etc., those are going to be the same. When you get a little faster here with this, then in order for that to happen, you've got to cover a little bit more, your ground speed as it increases, that angle has got to increase here as well. And so your feet per nautical mile is going to increase here. And so when you look at what it would be at 90, you'd have to say, okay, here if we need a climb gradient of 265, if I have a ground speed of 90, then that's going to equal 400 feet per minute. And that's what this box is right here, is feet per minute. So if climbing out with a ground speed of 90, 400 feet per minute will produce a climb per nautical mile of 265 feet per nautical mile. Got that? Because you're going faster at 60, okay, feet per minute, okay? You know, remember how the time thing goes? So that's kind of what that's looking at. The one thing I want to show you here before we leave this, and you guys can look at this and you can see how all of this works, but the one thing I want to show you before we leave here is where we are at 3 degrees. So if we look here at 3 degrees, that is going to be, in most cases, what your approach angle is going to look like. Most of the standard instrument approaches, the ILSs, they bring you in at approximately 3 degrees on your glide slope, which is that's that vertical track going above the ground. So that 3 degrees is kind of that magic number. So let's look at this again here. So if we look at this and we think, okay, here's our 3 degrees on our approach. If we have our ground speed of 90, that 3 degrees means that we are going to be descending at approximately just under 500 feet per minute. So if we are just under 500 feet per minute on our VSI at 90 knots, that produces a nice 3 degree glide slope. Why do I bring that up? When we're starting these approaches, being stable on those approaches, it's everything. So when we get to our final approach fix and we begin heading down the pipe, as we call it, or the hypotenuse, it's going to be about that 3 degrees. So you know that if you can adjust your airspeed to give you a 90 knot ground speed, then your approach rate of descent to give you that 3 degrees to keep you on that glide slope will be just under 500 feet per minute. The reason I say this is because it makes it real easy when you're doing this to set it up using these numbers. And this just shows you what that will do for you on your descent. So again, we use these numbers here on the climb out. We can also use it here on our descents. You may also have some of these things that are going to give you a steeper approach angle. For instance, if we take a look at this, I'm going to close out of this, move this, stand by here. If we look here, let me make sure I'm doing the right column here. So if we look here at Aspen, and we're thinking, okay, where's Aspen going to be in the mix here? And we're going to look at this. Aspen is going to be closer here to that 6 degree. And so where do you think that's going to put you here as far as a foot per minute descent? Yeah, almost 1,000 feet per minute, which is just a bit nutty. Because that's just, again, it's one of the things that makes coming in and out of Aspen, one of the challenges that we have is that you're basically following a trajectory not dissimilar to the space shuttle coming in here to land. Now, clearly I'm exaggerating there a little bit. So, just letting you know, that's how to use that chart. Okay, all right, back to the action. Now, we go over here and we look here, and I know that you guys have done the reading, and we are getting over to a place now where we can start looking at our clearance. So the clearance, this is this part over here that I just want to bring your attention to here. And we have a little acronym. Oh, and my Lord, why wouldn't we? We have a little acronym that we remember here as we copy down our clearance. It is CRAFT. Craft. We write that vertically. And for those of you that think that I'm, just kind of making that up maybe, I'll show you something here if I can get this thing to work correctly. Stand by. Here we go. There's that. Come on, baby. Why isn't that? Golly, I've got to figure out this doggone iPad because this thing is just, man, I think part of the problem that I have is that when I bring the iPad upstairs and downstairs, it goes to a different Wi-Fi frequency change that we have here in the house because we have one set up upstairs and we've got 3 set up downstairs with that. So it kind of messes with that, and it's like, okay, well, why do I need to know that? Well, come on, why isn't that? Screen mirroring. There it is. Okay. Now it should pop up here. And of course it's not going to. Golly, I just hate this when this happens. I've got to figure that part out. It's on the right deal. Open this up again. Guys, I'm sorry to slow you down with this. It's just, it worked in rehearsal. Yeah, I don't know why it's not doing this. I'm supposed to be getting a code here, and it's not giving me a code. Well, to heck with it. So what would happen is this, and what I was going to show you on the iPad, which in ForeFlight, which for whatever reason it's just not working right now. What you get is you get this thing. We have a scratch pad, and on that scratch pad, it'll show you this stuff right here. So it'll show you CRAFT. So as you look here, you can see that the C is going to stand here for your clearance limit. So where are you cleared to? Now, you could be cleared direct to the airport. that you have. So for instance, if I'm flying to, let's say, fuel stop coming out of Aspen and I'm going to Lawton, Oklahoma, Fox 10, I could be cleared to Fox 10. I could also be cleared to a VOR near Fox 10 to my clearance. I could also be cleared to a particular hold somewhere where I am going to be outside of some busy airspace, cleared to an area where I can expect to hold until they are able to fit me in based on the timing of my planned arrival piece. So that's kind of where they can clear you. And then you look at your routing here. Okay, how is it going to be cleared? Well, let's say that I put in the waypoints going between different VORs and going to, from Pueblo and kind of heading out across the panhandle of Texas and down through sort of central Oklahoma into Lawton. They could have all of those different waypoints or the Victor Airways they could list. So they would have a start point where they might want me to start at the Red Table VOR and then to go Victor 186 to wherever it's going to be, and then Victor 243, and then Victor 84, down to a particular VOR outside of Lawton, or direct to begin the approach there at Lawton. So I wouldn't necessarily write the airport here, since I know that my clearance has already been cleared to this airport here via this kind of routing that we have here. And then beyond that, they're going to give me an altitude. Well, they may give me an initial altitude, and they may say, on your altitude, climb 12,000 feet, and then expect 17,000 feet after 5 minutes. So we all develop our shorthand here as well. So what they may be trying to do is to try to keep me under a particular area here, and then after I get underneath a shelf or underneath some traffic and out in the open, they may allow me to go ahead and get back up here to a cruising altitude of 17,000 feet. So that's kind of where they're going to give me that altitude. Then also know that that's going to change. You may get up there at 17,000 feet and you may decide that your ride is a little bit rough. You want to get a little bit lower, use a little less oxygen if you're using a mask or a nasal cannula in an unpressurized aircraft, and get a little bit lower, maybe smooth out your ride. Maybe the tailwind is stronger down low. That would be rare. But that's kind of where it is. So if you kind of file for that 17,000 feet through there, especially coming out of the mountains, you can normally get a pretty good tailwind that kind of, pushes things along, and it makes it worth using oxygen for a while. Getting out there. So that may be where they give you your altitude. Then they're going to give you your frequency. So coming out of Aspen, you're looking at a frequency here of 123.8. That's going to be your departure frequency. And then after that, they may tell you, you can expect Denver Center on 135.6. Shortly thereafter, and you can kind of jot that down. And then under the T, that's going to be your transponder, and they'll say squawk 4236. So then, after they give you all of this information, then you got to read it back. So you're going to have to read it back to them to make sure that you and air traffic control are on the same page with regard to what instructions that they have given you. So you can also say, after they end the transmission, you can also key your mic and you can say, stand by for readback, and that allows you to kind of put things down, give you a little time to write and scribble over here, and then you would come back and you would say something to the effect of Aspen Ground 504 Hotel Lima, clearance copy. I am cleared to Fox 10 via Red Table, Victor 186, Victor 243, Victor 84, altitude 12,000, expect 17,000 after 5 minutes. Departure frequency is 123.8, expect Denver Center 135.6, and transponder 4236. Denver, and then the ground will come back to you and they'll say November 504 Hotel Lima, read back correct, cleared taxi, do you need a run up? They say, yes sir, I need a run up. Cleared a taxi to run up via Alpha. Hold short Alpha 4 for inbound traffic. Proceed on taxi via Alpha. Hold short of Alpha 4 for inbound traffic. Then you're holding inbound for traffic that may be crossing there at Alpha 4. And then ground will look at you there and they'll say November 504 Hotel Lima, continuing taxi to run up 504 Hotel Lima. And so you want to make sure that you are, when you're doing this, that you and ground are always on the same page. There was an incident that happened here recently where there were a couple of airplanes that collided on the ground out there, and one had the tail sawed off on one of these things. And so this has been a big thing with the FAA, I would say lately, like within the last 5 to 7 years. And actually, I think it happened even from the Canary Islands in the 70s when two 747s collided in the fog in the Canary Islands. And I have a story about that, but that's another time. And so ground incursion is a thing that the FAA, it's kind of been a big FAA hot button for a while. So we want to make sure that on the ground that we're doing what we need to be doing and making sure that everybody knows exactly what needs to happen during this little ground ballet as the aircraft are moving around, especially in tight quarters or in large airports. Okay, so that's kind of the clearance piece there and how that works. I am sorry that I cannot get the doggone Apple thing to work correctly. I'm going to have to figure out how to fix that because it's just maddening. So when you look at this and you looked at your clearance, you saw that there are several examples down here about how this clearance works. And you can see this, you can read, this is what you're given. And then in the yellow boxes here, they have given you examples about how you might shorthand that a little bit. But just also remember is that in ForeFlight or even on your knee board, you always want to start with this. And you may want to give yourself a little more spacing here between these two, especially as you start writing this down. But then you can start figuring out your shorthand and how it's going to work best for you so that you know not just what's being said to you and not just what it's going to look like for you on your way out, but again, so that you know how to read this back to your clearance delivery or your ground. So they've got several examples there with that. So there's all of your clearances. Just make sure that you understand those and make sure that all of those make sense to you. And so that is going to be the end on the departures. So the quiz on Monday, quiz Monday, is going to be on the departures here, and it's also going to be on airspace and VFR weather. Okay, so the quiz on Monday is going to be a little longer than normal. So go into Big Red. That's where you're going to see all of your departure stuff. And I told you this before. You can look at those chapters, find out where your airspace is located in Big Red, as well as the airspace stuff in Big Blue. Okay, because you're going to get part of the VFR weather stuff in the first part of the quiz that's going to be on the private pilot side, because you're not going to have VFR weather stuff that's going to show up on the instrument side. Why? Well, because you're in the clouds. So with that, there's going to be a two-part test. One of them is going to be on the license that you have with your private pilot. The other is going to be on the license that you have with your instrument stuff. So you'll have two different quizzes, one on private pilot, one on instrument, okay? And it's going to combine the departures. It's going to also have the airspace and the VFR weather. So you got plenty of time to study up on that and get ready to go, okay? That'll happen on Monday. It'll take you probably the hour on Monday. So be prepared. Don't wait to the last minute to start cramming for this, guys. Start working on it now so that it's not a surprise to you, because again, this stuff is coming in quicker, and the en route segment that we're getting ready to start that kind of overlays on the departure stuff, just remember what I told you about how this semester is going to go. It's going to be challenging. So keep that in mind. All right, guys? So there you go. I realize that this is not quite 40 minutes here, but it does end chapter 21. So that's going to be this. And so you guys can take the balance of the class hour for you guys to study quietly. And again, remember, email, text, questions to the Big Bald Man, and we'll get you guys squared away. Guys, I've gotten a couple questions from some of you already. Thank you very much for those. Hopefully that helped answer your questions. And yeah, there we go. Okay, guys, have an awesome day. Have a great weekend. Study, study, study. Quiz on Monday. Okay, guys, see ya. Have an awesome day.